Hey, thanks for joining us for this talk. My name is Justin Garrison. I am a senior developer advocate for Amazon, and it is my privilege to introduce this talk because I have uh, a lot of fun memories from my time at Disney and with Disney Plus, and helping them build their infrastructure for what Zach is going to talk about today. It's quite the amazing thing to be able to launch a large scale streaming service in this time of year, and just in general, it's been out for just a little while, and it's bringing you all your favorite characters, which I'm sure many of you are either subscribers or at least know of some of the things like Mandalorian and all the classic Disney films. So this talk is really about the technical details of what Zach's team does inside of Disney Plus to help developers deploy quickly and deploy at a global scale. I mean, look at the title alone. They are running this service around the globe in multiple different countries, and it's being reliable, streaming all those films whenever parents and children need them. And it's just a great thing to see what they were able to do for building on top of Amazon, taking advantage of the building blocks that Amazon provides, and in taking that into their own domain to be able to let the developers focus on what they do best. And it really is incredible. You'll hear in the talk that all the things Zach's team has been able to do over the years. Disney Plus doesn't happen overnight. It's been in the process of being built for quite a long time before it launched, and constantly iterates and new features come out to make the platform more stable, to make developers more productive, and really deliver value to any customers that are using it. Even look at new features that like group view and those sorts of things are all new features that developers had to develop and not necessarily think about all of the infrastructure. They needed a platform that was reliable and stable and allowed them to safely make deployments at scale in a global for a global audience. It's quite amazing just to be able to see it. So I don't want to take up too much of your time. Zach goes into great detail on kind of the process they took, what they decided on for how they're making this happen for developers, what a developer needs to bring to the deployment tool to be able to say, I need my service running at a certain scale, as well as just some of the observability pieces to understand when things fail or maybe don't go correct, just making that safe and making it easy for a developer to dig in and understand how to change it and make it right. All those things are super fascinating at such a large scale with something that moves so quickly. You'll hear how many deployments they have and how quickly they move throughout the talk. So without taking up any more of your time, here's Zach Bintliff with Disney Plus.
Thanks, Justin. Hi, everyone. My name is Zach Bintliff. I'm an engineering manager here at Disney Plus, and today we're going to talk about how Disney Plus deploys globally with Amazon ECS. To give you a brief overview of what we're going to do, first I'm going to introduce myself, the team that I'm on, what we do, and then I'm going to talk about ECS, why we use it, how we use it, and a platform we build on top of ECS. Next, I'm going to go into the goals of the platform, the features the platform allows, and how developers interact with that platform. As many of you know, Disney Plus launched a year ago, and millions of you have interacted with it via the apps and websites. There are many applications deployed behind the scenes to make sure you have the best customer experience possible. Those applications can be anything from DRM to analytics to search and suggestions. How those applications are deployed and making sure they're deployed consistently is one way we make sure you have the best customer experience possible. And that's where my team comes in. I'm part of a wider team called Developer Productivity here at Disney Plus, and our main goal is to make it easier to operate in the cloud. When teams move to the cloud, there's so many concepts they have to learn. They have to learn VPCs, security groups, networking, EC2, all of that. We want to make that easier. We want to make that the barrier to entry lower so people can just operate in the cloud easily. To do that, we build tools. We build tools to help them build their containers and deploy them to ECS. Specifically, my team focuses on deployment. To give you a sense of the scale that we're operating at, since this platform was designed in 2017, we have over 330,000 deployments. And I actually checked today and it's closer to 350. We have 700 unique applications that's been deployed. About half of them are currently active. And across all of our clusters and regions, we have over 40,000 ECS tasks. Now, if you look on the bottom, you'll see an upward trend of deployments over time. And while 20,000 deployments may seem like a lot in September, it's a number I'm really proud of. Remember, the goal of my team is to make deployments easy. So seeing that 20,000 is something that we really use and a key metric that we enjoy. But only a small portion of them are actually to production. A large majority, a large percentage, is actually people developing locally to try to find that bug, to work on their feature. They can just right from their workstation push and build something completely and see how it works. At the same time, because it's so easy to deploy, via Jenkins, we run load tests and performance tests almost constantly. Again, we want to make sure we're not pushing anything bad to production that can impact the customer experience. So now we're going to talk about ECS. Why did we choose it? ECS is a great scheduler. It does its job really well and offers a ton of features that we can use. At the same time, when we originally designed this program, we were a pretty small team. We had many different accounts and many different clusters we were operating on in many different regions. As a small team, we couldn't manage the control plane for all of that. Making sure the control plane is highly available 4 years ago was a very difficult task. So instead, we offloaded that. We let ECS do it for us. ECS does this job really well. All we have to manage is the actual compute layer. We deploy EC2 instances that have the ECS agent, and that's it. Some scaling rules, and it makes life easy. An upgrade is nice and safe. One by one, we can upgrade the ECS agent on the node, or if we really want to, we can spin up a new ASG and test it fully. Again, it makes it really safe, and we don't have to worry about the control plane. So now, internally, we call this platform a glue code as a service. Because once you deploy, there's so much around your container that actually matters. You have to worry about the load balancing, the target groups, the logging, the DNS, metrics, networking. All of that goes into a successful deployment, while container is just a small part of it. So what we tried to build was something that glues it all together to make life easier for everyone. At the same time, because we were going to have a central deployment platform, we could ensure everyone was following the best availability requirements and best practices. So what technology did we use? Obviously, we use Amazon ECS. Like I said before, it's a great service that does exactly what we need it to. But we don't actually interact with ECS directly. Instead, we offload the lifecycle management to CloudFormation. CloudFormation allows us to define templates that we can just rubber stamp out to actually create the load balancers, the target groups, and the service for us. But even then, we don't even just deal with CloudFormation completely either. We use something called Amazon Step Functions. Amazon Step Functions is a great tool, and I'm a big fan of it here at Disney+. We can define a workflow, which is just a state machine, and have all these individual steps do a part of the deployment. It's perfect for deployments. At the same time, Step Functions allows automatic backoff and retry based on custom error handling. It's something that we really use and makes deployment so much easier. We don't have to add that into our logic anymore. It's for free. We'll talk about it later about how we can use it. So what are the goals of the platform? We wanted to make it simple, so we made three very simple goals. 1, make it easy to deploy. 2, make it very difficult to make a mistake. And 3, we wanted to have default best practices. We wanted new engineers to join the team. When they join the team, there's usually a ton of context they need to learn. They need to know what decisions were made, how to deploy, how Amazon is architected, all of that. We wanted to take that all away. So new engineers should be able to deploy quickly. But at the same time, they should be doing it safely. They shouldn't bring down production on accident because they didn't understand how something actually works. So we wanted to make sure that there was guardrails set up to make sure people can move quickly, but safely at the same time. So the first step, make it easy to deploy. How did we do that? We required as few parameters as possible. So if you look on the left, it's a worker application. That's the spec. That's the absolute minimum you'll need to provide to deploy to production. But the first 5 fields are actually just metadata. That metadata lets us know what cluster to deploy to, and that's it. Everything else is just how many tasks you want, CPU, memory, and image, the bare minimum required. There's many other fields that we allow, but they're all just have same defaults to make sure you're doing and following the best practices. On the right is a load balance application. We need a little bit more information from you here, and that's because you're load balancing traffic. We need to know where to send that traffic, how to health check it, and all those, what CNAMEs to use and more. But still, it's not that many fields you need to actually get a deployment out. Continuing on, make it easy to deploy, we do something called preemptive scaling. First, let me take a step back. Our ASGs are out in production, and they register via ECS agent to ECS. There's definitely reactive scaling there. There's CloudWatch alarm set up to monitor CPU and memory usage based on load. When they scale out, this cluster will scale out. But at the same time, during the deployment, might not be the best thing. We want to minimize the amount of time. There's two different versions of the same code, same application out there, because that can cause conflicts. So if you look on the left, you'll see the cluster on the left won't fit that new service. It'll place one task, and the ECS has to wait for the cluster to scale before it can place the second. That means two versions of that deployment will be out there at the same time. Things can happen, things can break, and complications can arise. So instead, what we do is we look at the cluster on the left, and we see that that service won't fit there. So then we scale it out. Once we scale it out and it turns on the cluster on the right, we can see that the whole service will fit there. So we create the service via CloudFormation, and ECS can immediately place it. It won't get rate limited, it won't get throttled, and it won't go into any wait period trying to place tasks. It can immediately place them, and we can continue on with the deployment. We also wanted to make it difficult to make a mistake. And the best way we do that is something with load balancer preservation. Disney Plus is a large application. Many users interact with it every day. When that happens, behind the scenes, the load balancer is scaled by Amazon automatically to handle the load. They want to make sure all that load can be handled and passed back to the background. During a deployment, you want to make sure you don't lose that scale, because if you were to replace the load balancer during deployment, getting that scale back is a costly in both time and money process. So when we deploy, we actually swap out the deployments behind the load balancer. So every time you deploy, we find the correct load balancer and we make sure it's saved. We don't want to lose that scale. Again, it's something most engineers, including myself, don't think about until you deploy and you see a large spike in 500 errors. And that's because you might have lost the scale there. That's something we're trying to prevent. Now that we already established that we're keeping the load balancer, we do a full blue-green behind the scenes. Again, it's just safety. So when you do a deployment, we create a brand new service behind the target group and register it to the target group. And we wait for it to health check, and I'll go into the health checking later. But once it's considered healthy, then we tear down the old one. The nice thing about this is we never touch the old service. There's no mutation involved. That means if there's a rollback, we don't need to update anything to roll back. We just need to remove the new service. Again, it's just safety, having that baseline that we can always roll back to. That old service is never mutated, so it's always going to be able to serve traffic, and it will always be there. Continuing on, we wanted to make it difficult to make a mistake, so we safely determined the size of the scale of when you're deploying a scaling deployment. So the spec I showed you earlier only asked for a desired count. That was a static deployment. There's more options that, like I said, and one of those is a scaling deployment. You can define alarms and you can define the min and the max. We don't ask for the desired count in this situation. Why? Because if we ask for the desired count, it's one more thing for an engineer to get wrong. If I'm doing a deployment, I don't really care what it's currently at. I just need to make sure that it's within the bounds I care about. If I have to look up what it's currently at, it's one more thing for me to get wrong. I have to look up a deployment, see what it's scaled out, and then pass it to the new one. I can type that wrong somewhere, or a bug could pass the wrong number. So instead what we do is we only ask for the minimum and the maximum. When we ask for that minimum and maximum, we then look up during the deployment what the previous deployment it was replacing is scaled at. And then we set that going forward. So on the left, you'll see a scaling deployment with a minimum of 1 and a maximum of 5. Throughout its lifetime, it's scaled to be 3 tasks. So when the engineer deploys again, all they need to do is give us the bounds, the minimum and the maximum. We'll find that old deployment, see that it's scaled to 3, and set it. Again, just like load balancer preservation, we want to make sure there's as many tasks as there was before it to handle the same amount of load as before. This is my favorite part. We did robust health checking. So Amazon, we allow 3 different levels of health checking, most of them provided by Amazon. The first is at the task count. This is pretty easy. We look at the service and we ask if the running count equals the desired count. If the running count doesn't equal the desired count, we error out. This is when step functions really comes in nice. We have a custom error that we can say, hey, that's not healthy yet, retry. Step functions can capture that error, wait for 30 seconds, and retry. We do have an upper bound though. So as we continually do that, we wait until the running count equals the desired count. Once that happens, we move to the next check, container checks. So ECS supports native Docker health checking, which is great. What that means is the Docker daemon on the host will actually run a script to check the healthiness of your container. It's better than saying the container is up or not. It actually verifies that it's doing what it should be doing. Just like the task count, we sit there and we wait until it equals the desired count. Again, we'll back off and retry until it does. And then finally, we go to the ALB. We look at the target group and we make sure every single target in the new service is accounted for, it's healthy, and it's receiving traffic. Only after all three of those are healthy do we can mark the deployment as healthy and continue on. Now you'll notice only two of those are required, or two of those are optional. The container health checks and the ALB health checks aren't required. But still, we encourage all of our developers to use them to make sure that you're being as safe as possible during a new deployment. Now you also might think that times vary across deployments, and they do. A service with one task can become healthy or unhealthy much faster than a service with 1,000 tasks. We actually have some services out there that might be 2,000 tasks. It takes ECS a very long time just to place those. It can be 3 to 4 minutes just to place all those tasks on ECS nodes, let alone register them with a load balancer, mark them healthy, and direct traffic to them. We don't want the small service with one task to wait as long as it takes for a service with 2,000 tasks to become unhealthy. So instead what we do is we have a concept of healthiness. Every time we retry, we keep a state of how many tasks were healthy, how many containers were healthy, and how many were healthy at the load balancer. And as long as we see an upward trend there, we'll give it more time. That way the service with 2,000 tasks will have all the time it needs to be healthy, while the service with one task will fail quickly if it's bad, but then also be marked quickly if it's healthy. It's one of those things that developers don't really think about, but it gives them the same experience based on the size of their deployment, and it doesn't make the developer with the small task have to wait the same amount of time as a deployment with a large task. Unfortunately though, mistakes do happen. And when they do happen, we want to get those to the user. So throughout the entire platform, we're emitting events. We're constantly saying, this is where we're at, this is what's going on. We're creating the load balancer for you. We're creating the service for you. We're health checking. All that is constantly being emitted that the developer can describe those. But when they do fail, there can be many places that it fails at. Because we use CloudFormation, it can fail there. There can be errors on the stack. There can be errors on the ECS service level. There can be errors at the task level, and there can be errors at the container level. All of those requires the developer to, one, know that errors can exist there, and also requires them to know where to find it. Unfortunately, most developers don't know that. It's really hard to know, and some of them are hidden, especially on ECS when a container is already removed. So we do our best and get that information for you. The error you see here is a pretty simple error. I most likely mistyped the image name, but ECS can't find it, and that error is actually hidden pretty deep. It's not at the task level, or it's actually at the task level, which is 2 levels down. So what we do is we go there and get it, whereas engineers might not know out of the box where to find that error and easily fix it. So now we're moving on to default best practices. When I'm deploying to an ECS cluster, I don't really know anything about the compute. I kind of know what region it's in, but I don't know which AZs or how many AZs or any of that. So what we use instead are built-in ECS placement strategies and constraints. The first two we use are availability zone spread and instance spread. So AZ spread is really nice. It makes sure that all of your tasks in a service are spread across all 3 AZs at least. This is good because sometimes there are networking issues that impact an AZ. You want to minimize the impact that has on your service overall. So what that does is make sure that when that happens, only 1/3 of your service is potentially impacted, while the other 2 can still service requests. We do the same thing with the instance. We have a shared cluster, so we have a lot of compute and many nodes in that cluster. So ECS instances die all the time. It's just the cloud. It's how things work. They're always constantly coming up and going down. We want to minimize the impact that has on a specific service. So what we do is we spread across them. We make sure that when a node goes down, the impact on the actual service is probably only be one of many tasks. Again, minimizing the impact that has on your deployment. ECS also supports tagging and container labels. This is great. So ECS supports tagging on many levels, at the task level and even the container level, and runtime container labels that we can pass onto the containers. So what we do there is all that metadata that we use and collect to map to a cluster, we add it to to the deployment. At the same time, we have even additional metadata we add. What this allows us to do is during a deployment, we can give a direct URL to the developers that they can find metrics to track and see what's going on inside their containers. This is great because they'll be able to know, oh, there's a big spike of CPU here, something's wrong, we need to roll back right away without having to look for it. At the same time, we do the exact same thing with logging configuration. On the spec I showed you earlier, there is no fields for logging. That's because we default send to our vendor and we have everything properly indexed and we can give them a direct link to it. Again, just like the metrics and the resources, everyone knows exactly where to go to find where the deployment is. But if they wanted to override it and actually send their log somewhere else, they absolutely can. That's something we allow and teams can do that, but they just lose the ability to have that direct link automatically. The last default best practice is a deterministic DNS name. So when a developer deploys, we use that metadata, and if we manage a load balancer for you, we set an alias record. This is great because developers know where their deployment is going to live. They know exactly how to reach it, and they know how to hit it. This gives them so much control because if they had to do a migration, like a hard-breaking migration that they couldn't do a blue-green deployment behind the scenes, they own what the CNAME is that points to that alias record, and then they can own when it gets cut over during the next deployment. They won't have to talk to their clients, and they won't have to do anything else. It's just done for them. So how do developers interact with this platform? It's easy. We provide a CLI that they can use both locally and on Jenkins. The key thing about this is our CLI has its own authentication mechanism. That means a developer doesn't need to worry about Amazon, which account they're operating in. There's no need to know, anything with Amazon at all, set up credentials, CLI, nothing. They can just deploy as easy as that command is there. You just say create deployment, you pass the spec. Again, that spec looks like the spec file that we showed earlier. And that's it. The platform figures out all the Amazon context for you, assumes role into it, and does everything on your behalf. So what are some other features we allow? We just launched canary deployments using weighted target groups behind a load balancer. This is great. You can have a weighted target group by a percentage of traffic from 0 to 100 between two different deployments. This allows you that much more safety if you wanted to test a new feature, do some experimentation, or just slowly roll out a new feature over time. We also provide the ability to diff two different deployments to track changes. For example, if you look below, you'll see that maybe my deployment 1, 2, 3 in this example failed. I don't know why. But if I do a diff, I can see from the previous deployment, my container port and my protocol changed. That's probably not something I wanted to do, and it's probably why my deployment failed. Along the same lines, we also provide deployment lineage for easier rollback. So when I'm deploying again, we keep a pointer back to the deployment it replaced. That means that some bugs take a while to manifest. It can be a slow memory leak or some hidden edge case during failure scenarios that isn't accounted for. But if you know it wasn't in the previous version, you can immediately go to the other version and redeploy safely. Just one of those UX features that we try to provide. So to quickly recap, on the right-hand side, you'll see the state machine. It's a simplified version of the state machine that we use, but it basically is all there. We map it to all the metadata to a specific cluster. We create the load balancer and the target group if it's needed. We scale the cluster if needed, again preemptively. We create the service. We then run the health checks. All three of those health checks are ran there, making sure that everything's verified and we can go on. We update DNS if it's successful, and then finally, only then do we tear down the old service. On the right, you'll notice that everything goes back to a single state, which is rollback. We're creating things on people's behalf, so we have to make sure we clean up everything. If we leave resources dangling, it's a waste of money and potentially can cause issues in production. So we have to make sure that every single execution is fully accounted for there. And with that, hope you know how we deploy safely and globally at Disney+. Thank you. My name is Zach Bentliff. Please complete the survey after this session.